Chapter 5 is on quadratic functions, and the first thing we'll be doing is looking at properties of quadratic functions. Guess we better start by saying what a quadratic function is. A quadratic function can be written in the form y equals ax squared plus bx plus c, but it's only valid if a, b, and c are real numbers. Basically all the numbers we deal with in high school, so no big deal there. And a cannot equal 0. Why can a not equal 0? Because if a equals 0, you would have no x squareds, so you'd actually end up with something like y equals bx plus c. And if you have that, you actually have not a quadratic function, you have a linear function, right? That's like all the things we've already done, graphing in grade 8, 9, 10. You'd had things like y equals 2x plus 3, or y equals negative 1/2 x minus 4. Right? In this case, these are linear. What makes a quadratic is that x squared part. So you can't have a 0 there, or you'd have no x squareds. Alright, let's move on. So I already said this, well, no, I didn't say that. They're second degree polynomials. Quadratic functions are second degree polynomials. Now, I don't want to really get into degrees again, but basically degrees is looking at the exponents on the variables. So the highest exponent we have in here is a 2, and that's why it's a second degree polynomial. And that's what makes something quadratic. That's why, as I said, you can't have 0 here. Otherwise, you have no x squareds. The highest exponent you'd have on a variable is a 1, so it wouldn't be quadratic. It would be linear because it would have a degree of 1. But this one has a degree of 2. And all the graphs will be parabolas for quadratic functions. A parabola is like this shape, this blue shape right here. That is a parabola. Okay, so what this section is all about is looking at the properties of this, or not particularly this parabola, but of parabolas. What are some of the features that we can identify of a parabola? Okay, well, one thing is the y-intercept. So we've talked about y-intercepts before. What's a y-intercept? A y-intercept is where the parabola crosses the x-axis. So in this drawing here, the y-axis is right there. That's where it crosses the y-axis. So if we were going to name that point, if we were going to say what the y-intercept is in this case, you could just say -3, or you could actually name that point 0, -3. It's probably a little safer to write this, or if it's really clear you're talking about the y-intercept, you could just say -3. Okay, how would you find the y-intercept if you just had the equation? Well, what you do is you set x equals 0. Remember, every point on this y-axis here has an x value of 0. This point here is 0, 3. This is 0, 2. This is 0, 1. This is 0, -3. This is 0, -5. They all have an x value of 0. So if you set x to 0 in the equation, plug 0 into all the x's, you'll find out what the y value is at that point, and that'll be your y-intercept. Okay, how many y-intercepts can there be? Well, there will always be exactly one y-intercept. Now some people say, I don't agree with that, Mr. Wadge. I think if I had a parabola that looked like this, I would have no y-intercept. It doesn't look like it is going to have a y-intercept, but remember, this is getting wider and wider and wider and wider here. Eventually, somewhere way up high, that's going to cross over the y-axis. Okay, so that's always the case where there's a one y-intercept. Oh, wait a minute. Some of you might have said, well, wait a minute, Mr. Wadge, what about something like this? And that's good thinking. That would have no y-intercept. However, for grade 11, we will not be dealing with parabolas facing out to the left or facing to the right. All our parabolas will either face downwards, like this one, or will face up. Okay, so everything I say here about the properties of parabolas, it's based on the fact that we're only dealing with parabolas facing down or up, no sideways parabolas. Alright, next thing, x-intercept. Well, that's pretty clear. If we know what the y-intercepts are, we should know where the x-intercepts are too. They are the points where it crosses the x-axis. So we have one here, and we have another one right there. If I was going to name those, I would say that this one is 1, or I could be more specific and say 1, 0, and this one is 3, or I could be more specific and say 3, 0. So these are the points where the parabola crosses the x-axis. Guess how those can be found? Well, all the points along the x-axis all have a y value of 0. This is 1, 0, 2, 0, 3, 0, -2, 0. So this time you set y equals to 0 and solve. It'll be a little bit more difficult, and we'll show you an example of that later. How many can there be? There's 2 in this case. Can you think of some other possibilities? Well, you could have none. How could you have none? What if it looks something like this? Right? That's never going to cross the x-axis. Same if you went like this. Never going to cross the x-axis. Any other possibilities? You could have none. You could have 2. You could also have 1. What if the lowest point was right there and it went like that? Or what if the highest point was right there and it went like that? So you can have 0, 1, or 2 x-intercepts. So let's write that down. Next is the vertex. This is the most important point to the parabola. This is that point I was just talking about, the highest point or the lowest point. So this is our vertex right there. So how it's defined, it's the highest point or the lowest point of the parabola. In the parabola we're looking at right here, the parabola is, or the vertex is 2, 1. You must say 2, 1, of course. There's no other way to name that point. So 2, 1 is what you would call it. There's different names for the highest point and lowest point. If it's the highest point, like this one, that is called the maximum. And that makes sense, right? That's the highest point or the maximum point of this parabola. If you had a parabola facing upwards like this, or opening upwards we say, then the vertex is down there, and that is called a minimum. There's no point lower than that point, so it's the minimum value or minimum point. Next, axis of symmetry. So for the axis of symmetry, what does symmetry mean, first of all? Kind of makes you think of mirrors or something, right? It's when one half of something looks exactly the same as the other half. So there is a axis of symmetry here. I will draw it in with a dotted line. There we go, I've put it in red. And you can see that line is like a mirror line where the left-hand side of the parabola totally matches up with the right-hand side of the parabola. It's like they're reflections of each other. And this is the axis of symmetry. You'll notice that the axis of symmetry goes right through the vertex, and that'll always be the case. So it's the imaginary vertical line that passes through the vertex. Notice it's imaginary. It's not really there, right? I just drew it in now, but it wasn't really there. It's just an imaginary line. And the equation is always going to be x equals m. Huh? What am I talking about? Well, if I wanted to name this line, this dotted line right here, how would I name that? Think of all those points. This is the point 2, 0, 2, 1, 2, 2, 2, negative 2, 2, negative 3. Oh, it's all the points that have an x value that's equal to 2. So basically the equation is always going to be x equals m, where m is the x coordinate of the vertex. So for example, if you had a parabola that went through the point 7, negative 3, then the axis of symmetry would be at x equals 7. Even without drawing it, I know that that's a fact. Okay, that'll always be the case. Okay, next is domain. Remember domain? Domain is all the x values that are associated with the parabola. So if you think of this parabola and look at the x values, remember this is getting wider and wider and wider and wider, so it's going to eventually go, well, not eventually, it is going forever to the left. And if you look here, it's getting wider and wider and wider, it's going forever to the right. So the domain is going to be from negative infinity all the way up to infinity. Remember doing this last year? And that's always going to be the same. Remember that I'm only dealing with parabolas that are facing down like this or facing up. And because we're only dealing with those ones, the domain will always be all real numbers. So domain's the x values of the parabola, and it's always going to be, you can write it in 2 ways. You could say x is an element of all real numbers. Remember we wrote it like that before? Or you could write the other method, which is from negative infinity all the way up to infinity. It's the same thing. You can see 2 ways you can write that. Okay, range. If domain is x, you might remember that range is the y values. So if we look at the y values of this, it goes down and down and down and down. Down forever. It goes all the way down to negative infinity. It goes up and up and up. Whoop, that's the highest point. Remember, it's a maximum. So the highest point is 1. So the one we have here, this parabola we have here, it goes from negative infinity up to 1, including 1, so I put a square bracket. Or the other way you could say that is all the y values are less than and equal to 1. And in fact, it's very similar. It's always going to be like this if you have a maximum like we have. We have a maximum. If it opens up, well, let's start with this one. If it opens down, like this one we have right here, the parabola is opening downward. And if that's the case, your equation is always going to be y is less than or equal to n. What's n? N is the y-coordinate of the vertex, right? If you look at my range right here, y is less than or equal to 1. and 1 was the y value of the vertex, so that worked out perfectly. The other way you could write this is it will always be from negative infinity up to n. That's the other way you could write it if it opens down. Now if it opens up, again, n is going to be the y coordinate, of course. It's not going to be y is less than or equal to n. It's going to be y is greater than or equal to n. In other words, it's going to start at n and it's going to go up to infinity, like that. And that'll always be the range. If it's opening up, it'll be in that form. Okay, you'll get used to this. I know it sounds pretty complicated, all the stuff I've done here, but you're going to get used to it. In fact, we'll do an example right now, and I bet you'll surprise yourself how much of this you understand. Okay, this parabola right here, let's find the vertex. Well, that's not bad at all. Here's the vertex right there. What's that point? -1, 4. I'm finished. Hey, that was pretty easy. The axis of symmetry. So again, I'll draw the axis of symmetry. You don't have to, but I'll draw the axis of symmetry in case you don't know what I'm talking about here. There we go. What's the equation of the axis of symmetry? Now, oftentimes people just put -1. That's not an equation. Remember what we said? We said that the axis of symmetry will always be x equals m, where m is the x coordinate of the vertex. So in this case, it should be x equals -1. And if you look at that axis, yep, that goes through -1. All those points have -1 as their x value. That's definitely the axis of symmetry. Y-intercept. Y-intercept's right there. You could just say 3, but I prefer 0, 3. X-intercept, or intercepts in this case, I have one here. That's at -3, or I'll say -3, 0. It's more specific. And I also have one at 1, 0 as well. That's an S for x-intercepts. Domain. Don't even need to think about this question when you have it in pre-calculus 11. Domain will always be x is an element of all real numbers, or if you want, from negative infinity up to infinity. That's horrible, but that's negative infinity there. The range, you do have to think about a little bit. We have a maximum here, so in other words, all the y values are less than or equal to that maximum, and the maximum's at 4. The other way you could write that, it goes down forever, down, 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 so to negative infinity, but it only goes up as high as 4, inclusive. And is this a minimum or maximum? Well, that's the highest point. This vertex is the highest point, so it's a maximum. And what we say is it's a maximum of 4 when x equals -1. Sometimes it's written like that. Or you might just be telling me it's a maximum. That's fine too. Okay, that's the end of the video. I'm sorry for some of the bad editing in this video, but it's because I'm using a pre-calculus 11 video. And so the rest of the videos in this chapter 7 that you're working on in Foundations 11, probably a lot of them will have this kind of abrupt editing as well. I'm sorry, but I wanted to save myself some time. Take it easy.